Okay, everyone, it's 2 o'clock, and therefore I would like to welcome you all. So nice that you're all here, and I welcome you to our International Research Symposium in PBL and these flipped sessions where we will share the insights from our papers. We will do that by having 3 presentations, and in this session we have the theme Development and Awareness of Future Competences and Learning Spaces. 3 interesting papers. They will all be presented 3 to 4 minutes each. And after that, we will have a nice discussion. And please put marks in the chat, just a cross or something, so I can see that you want to join in the conversation. And then I actually think that we should be going. The first paper we have, the first presentation, is termed The Effectiveness of Teamwork on Students' Engineering Professional Identity Development in the AAU-PBL Model from the Perspectives of International Engineering Students, and it's presented by Mrs. Jubei Chen from Aalborg University. Please, Jubei, the screen is yours.
Hello, I'm Jubei Chen, a PhD student in UC-PBL Center. I'm glad to share our study, which is conducted together with Professor Annette Comast and Professor Xiangning Du. It is an exploration of the role of teamwork on international students' engineering identity development through AAU-PBL model. Engineering identity has been regarded as a significant indicator for students' professional persistence and competence development. Many studies have explored the components and measurement of engineering identity. However, most research mainly focused on individual learning process, and it is still unclear about the role of teamwork on students' engineering identity development, especially in PBL context. In this study, we focused on international students who hasn't experienced PBL in their home countries and aim to answer the following research question. From international students' perspective, what major components of their engineering identity have been developed under the AAU-PBL model? To have a structured understanding of engineering identity, we use Goldwyn's model, which has 3 dimensions: performance, recognition, and interest. Performance means students' beliefs of their abilities to do well in engineering. Recognition means students feeling that people around them recognize them as good engineering students or future engineers. Interest means students' curiosity to explore STEM fields. And in this study, we used a qualitative method and conducted 6 semi-structured individual interviews. Data was both coded by theory-driven and bottom-up methods. Themes and codes related to engineering identity in the 3 dimensions were identified. In the dimension of performance, we found students could enhance their engineering identity by linking theories to practice and improving their transferable skills through teamwork in PBL, such as communication skills, presentation skills, problem-solving skills, and so on. In the dimension of recognition, students become more confident because of others' positive feedback and recognition, and they began to realize the benefits of PBL to help them better prepare for future jobs. In the dimension of interest, students could share interest among team members, and some of them developed new interest in problem solving. However, not all students experienced successful teamwork. One of our participants mentioned the ineffective communication in her group and reported that she preferred jobs with less teamwork in the future. In general, although AAU-PBL model was identified by international students as an effective way to develop their engineering identity, challenges were also mentioned during the interview, such as cultural difference, transforming from traditional learning to self-directed learning, heavy workload, and ineffective teamwork in PBL. So the PBL curriculum for international students could be optimized with more PBL and teamwork skills training. And we call for more attention to focus on those challenges faced by PBL beginners and welcome more discussion about these topics. Thank you.
Thank you very much, Jubei. Very nice presentation. Kind of makes you think about what your own engineering identity is, being an engineer. So then we'll move for the next presentation, and this is with the title Fostering Creativity in Engineering Through PBL, and it's presented by, and now I have to be careful with the pronunciation, Mr. Oscar Ivan Higuera Martinez from University Pedagogical y Tecnológico de Colombia. I hope it was not too bad. Please, Oscar.
Good morning, good afternoon. I am Oscar Higuera, a PhD student. Today we are here with my advisor Liliana Fernandez. We work with Signal Processing Research Group at Universidad Pedagógica y Tecnológica de Colombia. In this work, we try to introduce a discussion about why it is important to foster creativity in engineering programs and how we can do that. Creativity is a necessary skill for science and engineering professionals because the design process allows us to achieve innovative and potential results for humanity's well-being. Creativity allows us to propose new products and processes for facing challenges and to find new solutions and well-known problems, and to generate new economic sectors and markets. Creativity has always been important. Thanks to it, the caveman created the wheel, and today allows us to design new gadgets. However, if creativity is crucial in engineering for social and economic developments, why it is overlooked in engineering education? This last reason motivates us to know about what happens with creativity in engineering education. In the published conference paper, we present an introducing literature review that focuses on practices oriented to fostering creativity in engineering. We wanted to identify successful teaching and learning experiences for nurturing creativity because we consider that it is essential in the digitalization era, which engineering design is a key issue for engineering is to realize its full potential. We found that some authors consider practices, scenarios, activities, and tools designed to promote creativity in students by using problems or projects as catalysis for creativity. Usually in literature appears as factors for promoting creativity, originality, fluidity, flexibility, elaboration, and divergent and convergent thinking, among others. We found 6 kinds of practices to promote creativity, such as complementary activities to training through scientific creativity, collaborative work, or inclusion of elements of creativity, mathematics and creative strategies, disruptive activities which combine arts and other disciplines with engineering design, laboratory activities which seek to strengthen the concept of science and engineering, course in creativity or training during different sessions throughout a semester, enhancing in students the comprehension of creative concepts. We highlight as a central approach to promoting creativity the solution of problems and the execution of projects. In this case, some works consider different strategies using the projects as the central axis without the follow a PBL alignment model, and others use the PBL approach to promote creativity. The promotion of creativity in engineering curricula is a primordial need in engineering education. Future engineers must think creatively, considering the challenges they will have in their professional life. Creativity will be responsible for innovation and new developments in engineering. PBL has some aspects that provide conditions to foster creativity, such as problem orientation and project work, group learning context, and the shift from teaching to facilitation. Recognizing this aspect, we propose that we can contribute to solution the problem of fostering creativity in engineering by the integration of PBL and creative techniques, promote creative thinking in ICT engineering students, and contextual challenges potentialize creative thinking by improving engineering design skills. Regardless of the chosen approach, it shows the needs intend to nurture 7 elements: the group learning, problem solving, project management, facilitation, enhancement of the environment, generation or exploration of new ideas, and autonomy. Thus, the alignment of these elements become the main challenge for offering an appropriate learning environment to develop creativity. Thank you for your attention, and we invite you to think how to promote creativity in engineering curricula. Thank you.
Thank you very much, Oscar, for a very nice presentation and also very interesting to discuss design skills and creativity as future competences. We have yet another paper before we should discuss, and the third paper is entitled Cross-Disciplinary Project-Based Learning in the Context of Building Information Modeling, and it's presented by Tom Radish and Johannes Schüler from HTWK Leipzig in Germany. So please, Tom.
So I would like to share the screen. I hope now you can see my presentation. Fine, so I can start. Dear ladies and gentlemen, welcome to the presentation of our best practice paper with the title Cross-Disciplinary Project-Based Learning in the Context of Building Information Modeling. At the beginning, I would like to briefly introduce you to the authors of the paper, Professor Ulrich Möller and Tom Radish, both of which teach at the University of Applied Science in Leipzig in Germany, complemented by Professor Carsten Menzel and me, Johannes Schüler, both of us teaching at the Technical University in Dresden. The center goal of our paper was to document the implementation of the PBL approach in an inter-university seminar in the context of building information modeling, which I will refer to as BIM from here on after. So we would like to present the related concepts of the BIM seminar and to share our experiences. Since some listeners might not be familiar with the concept of BIM, I would like to give a short introduction to the topic. As you can see in the figure on the left side represents the communication process is used in the building industry so far. There's always a bidirectional exchange, we can see, between the numerous participants in a typical construction project. This is very time-consuming and error-prone, as information is only exchanged between two parties. And to avoid these errors, the methodology is introduced as shown in the figure on the right. So here is a central information pool to which all partners involved in the project must communicate and exchange information. The most important thing is that all partners speak the same language for communication, and the same applies to the software by which the secure data exchange has to be guaranteed. So here and after, I would like to present the seminar structure of the PBL BIM scenario within the framework of the joint seminar by HTWK Leipzig and TU Dresden. As you can see on the left side, at HTWK Leipzig, students were enrolled in an elective master module where the students came from different specializations. At TU Dresden, the students were also enrolled in different specializations, but the separation of the teams is followed by the spatial structure of the building. A total of 50 students participated in the PBL BIM scenario, working on the same project. All of them dealing with an individual specialized task, and therefore the students were provided with a basic framework for a building to be planned. In the presentation, you can see the result of the project's work as a complex of two buildings connected by a steel frame structure. Each student cohort was responsible for one distinct part of the building. So the left part of the building was planned in Leipzig and the right part was planned in Dresden. The collaboration between the students from Leipzig and Dresden took place through virtual meeting rooms as a local platform called Opal, which is a web-based teaching and learning platform. And so now I would like to hand over to Tom for the second part of the presentation.
Yes, perfect, Johannes. So thank you very much. Maybe you go to the next slide. Yes, so in the following part, I'd like to present the overall didactical concept of the module. So this was based on the 7-jump model of Maastricht University that you can see on the left side. Yes, and the original 7-jump model structures the learning process into 7 steps, from clarifying terms to the synthesis of the solutions. As a mixture of group work and independent work. And the concept of our BIM course, presented on the right side, extends this 7-jump model to kind of problem-based project work. So what does that mean? The 7-jump model concept is based on the idea that students independently acquire the basic knowledge by means of any trigger and thereon define the problem to be investigated on their own. But in our case, yes, some initial support was provided to students by the teachers, because since a large number of students had to work in a collaborative manner, all of them working on a very individual task, it was decided that teachers should provide the initial specification and framework to be worked on, but at the same time, this framework offered freedom for the interpretation and exercise of roles and tasks. So a multitude of open questions in the project leads to the self-organized, creative, and independent process of PBL. Yes, and finally, I would like to address the feedback of the students, because in the beginning of this project, students reported that the various degrees of freedom in our scenario were very new to them, as they had previously participated mainly in direct instruction projects. However, students learned to master these challenges quickly, and in particular, the ability to personally take over the responsibility for creating models, for communicating, as well as managing data and tasks, increased students' confidence and practical experience. So finally, we can conclude that the focus on the self-directed learning and the interpretation of the teacher's role as a facilitator contributes to such a shift from teaching to learning. And now we are looking forward to discussing these experiences with you. So far, thank you for your attention. And if you have any questions, don't hesitate to ask us.
Thank you very much, Johannes and Tom. A very nice presentation. And also we have a new competence areas here focused on interdisciplinarity and getting people to work together, and also the transfer from one type of model and PBL model to another. Very, very interesting. I think I will now open the floor for questions. Jump in, you can type the questions in the chat, or you can just make a mark, and then I will ask you. Annette, you have a comment in the first, in the chat.
Yes, thank you. I was just thinking about, thank you to all the 3 papers. I think this is really interesting. I don't know how to link the last paper in, but that will be more on interdisciplinarity. But the first 2 papers, I think creativity, we talk so much about creativity. And my question to both of you, it's actually to both the papers, is anything in the data where we can see that engineers, that creativity is a part of the engineer's professional identity? Or is it something that is outside this?
Well, this is really interesting. And when I do the interview, when I ask students, how do you think about the work of engineers? And many students give me the feedback of they perceive engineers who create new things and to improve the quality of people's life. So, and they also believe when they do project to solve those real world problems, they are training their creativity. and they realize the importance of creativity through the training of PBL. So I got some data from students that creativity is a part of engineering identity. Yes.
The creativity is necessary to improve more in the all environments. Because, for example, in some cases, the only answer of the student possible is the teacher answer. And because this aspect, the creativity is more necessary, because not all students are the same aspect in your formation, but in the professional life, it's necessary to creatively. It's foster and need more foster in this moment.
Yes, and I think that creativity was also part of our project, because they, of course, they had an imagination of the building that has to be the result of the project, but all the processes of communication. So do I send the others an email, or do I use some forums or video conference systems and to do some protocols and that. So how does that go together? That was a question of creativity belonging to the processes of yes, doing such a project. And I think that that's really motivating for the students, because they get more self-confident that they organize the project, and it's not all based on the ideas of the teachers.
Right, since nobody has put a mark, I'll just jump in. I have the opportunity. I would like to ask about this because both you, Jubei, and Johannes and Tom, you talk a little bit about language or negotiating. So if we take Jubei first, this negotiation of meaning. How do the students actually go about doing this?
Well, it is interesting when I do a group interview, because when if I ask students directly, how do you think about engineering identity, student, they won't, because this question is too abstract for them. But when I conducted a group interview, there are still students in the interview, and I can see they began to discuss about the meaning of engineering identity. How do they think themselves as future engineers? And they have different thoughts and can inspire each other. And I think this is an example of what they do in their project when they have group discussion and something. Yes, they are construct the meaning of knowledge and their experience together.
Yeah, very good answer. I think it's very important that you actually come in and prompt them to do something and to talk and to reflect upon their own engineering identity. Keeping in the language, and then we'll turn to the Johannes and Tom. You mentioned that there were different languages when the students or the participants came about and worked interdisciplinary. How did you actually facilitate this, getting a shared language?
Johannes, would you like to start?
Yes, of course. I meant with they are using, or they have to use the same language as a symbolic sentence. They were all native German speakers, but there are some special words for some building elements which differ a little bit from region to region, and so for this reason I meant they need the same
so
meaning.
It was not a cultural thing. I was thinking that they were for different disciplines, and therefore they had different disciplinary cultures. So that was not in play.
I just meant building element names. So because there is a big international building element dictionary where from different cultural languages the names are compared.
Oh.
Yes, but it's also important and to when all the people are working at the same project, so there are also some technical, maybe I can share my screen for a short time. So can you see this platform here? So we just use for the project a central platform for the communication. And there all the issues, so all the tasks to be done, they are organized. Oh, I'm sorry. From the last year. All the issues are documented here, and the tasks are belonging to the model. So you have the people who have to do the tasks, and you have some dates, and you can always see where in the model you have to do these tasks. And so the different teams had the opportunity to communicate and to organize them with such central platforms. And that's the idea of BIM, so coming together at central points and to have a synchronous communication.
Very interesting. So we're actually using the building as a boundary object, you can say, for communication. Ron, you have a question?
Yes, thank you, Jette. For paper one, I would just like to understand a little bit more detail on how the enactment of PBL, you know, some of the nuances of how that fosters the development of identity, or in what ways might it impede the development of identity?
Yes, in this study, we have a framework, a theoretical framework with 3 dimensions of engineering identity: performance, interest, and recognition. So we explore the role of teamwork in PBL on students engineering identity development in the 3 dimensions. And in performance, first, students through PBL, students can realize the importance of transferable skills and can improve their transferable skills, such as teamwork skills, communication skills, and project management skills, and so on. And PBL provided them a chance to apply theoretical knowledge into practice, and which make them they are work as engineers, and some of them have the opportunities to work with real engineers in company, so they can experience the real life of engineers' work. And in the dimension of recognition, students can get positive feedback because they have more connection with their supervisors, the real engineers, and all people in the industry. And in the dimension of interest, students can share interest with each other and develop new interest in problem solving. As one participant reported, at first he wasn't interested in the one engineering topics, but when his group member proposed that issue, he began to think, that's really a problem. So he become more interested in that topics and work with his group members to solve that problem. And we have some emerging codes in our paper based on qualitative analysis. And there are more details in the papers.
A quick follow-up.
Mm-hmm.
Do they develop these skills just as a matter of course and it happens implicitly, or is it somewhat how explicit were they, as a part of the PBL enactment, have to identify what skills or experiences they're having? Do they write reflections? Do they find some way to process this development, or does it just sort of happen as a result of having gone through PBL?
Well, in this study, we interview international students who haven't experienced PBL in their home countries. So we ask them questions to compare the difference experienced between traditional learning and PBL. And we can see for example, in their home, they have experienced about teamwork in their home countries, but that's not true teamwork, because they just divided the tasks and finished individual tasks and put it together. But now they have more communication, and they know what each other's task, and they have an overview of the whole project, which makes them believe they are on the right way to become engineers. Yeah.
Thank you very much, Dubey. Annette, do you have a question?
Usual thing, unmute. Yes, it's for the BIM project, because, and especially now when we have the Corona situation and we go more and more online. So my question is actually, what in your opinion were the disadvantages by using BIM? And also with the communication, did it really facilitate the communication, or were there any barriers created like this? I know that the BIM, that it's very much, you have a function and you have steps, and it's very structured, but still there might be some issues.
Yes, I think the hardest problem for BIM is from a technical point of view. Maybe you can see my screen. Sorry for being that stuff in German. So there are different workflows you need to communicate and to collaborate in such projects. And things like referencing and coordinating each other that are working right well. But there are other parts when we exchange data. There are some faults because the software isn't functioning so well right now. So maybe just a simple example, here we have a model of a building with the windows, and we take it to another software. And so on the left side, you can see where the windows they are turned, and the software can't interpret it right. So yes, we are working on this stuff, but from a perspective of PBL, where in the center of our interest is the part of communication. There we think that BIM doesn't really has much disadvantages. So in real life projects, the disadvantage may be that it can lead to higher costs, because you need persons doing the BIM coordination. So there are some extra tasks, and for that people are paid in addition. But the result of this is that you have a better communication process and a higher quality of the planning results.
Can I ask an additional question to that? Because I think when we have students working with practice and things that needs to be implemented, they really need an overview of the whole process. They need to have this system approach somehow. And would you say that the BIM system would facilitate that?
I don't know the word facilitating so well.
Facilitate, how is that? As guide, help?
Ah, yes.
Yeah.
So the BIM is a methodology. You have to know. It's a method to plan. So we see that when we go into the project, the students have really a large amount of questions, because they don't know how to handle the software. They don't know how to handle the communication process. And therefore, we give to them one large lecture where we give them all the structure, and where we give them literature, and where we give them videos for the software, and where we explain to them the structure of the project and all like this, so that they have a good overview over the project and where they find the information to get a deeper knowledge of all that stuff. And I think it is very important, and we improve that every year, that this part of introduction to the students has a very good organization, because there are all the different students with different tasks, and yes, you have to pull them in with a good overview over all the project organization. But if you get by with that, if you have a good introduction to the setup of the project, then they can, from week 2, week 3 of the seminar, from then on, they can work very individually. And we are only there for some consultation, but there are no lectures anymore. And then they structure the process on their own, and yes, they realize that they are more efficient in comparison to, yes, only using emails and only using plans and 2D drawings and that.
Thank you very much, Tom, and thank you, Annette, for the question. Oscar, I would like to ask you about, because when I'm looking back and I'm thinking about creativity, there was a lot of discussion about creativity as an individual competence and group creativity. Have you experienced this kind of group creativity in your work with your students?
My experience, I implement a course with PBL alignment in signal processing. In this course, I see that the students explore different aspects, but the creativity is individual. But in the team, the creativity is more interesting, because the interaction in the other people increase the creativity, increase the more ideas, other ideas, other aspects that in one aspect I don't consider, but the student is very interesting with work with teams. It's more effective, that creativity that promote individual creativity with work in teams is more interesting and more effective. The collaborative work is necessary. In the real life, the collaborative work is all time. For example, in this moment, we work in collaborative teams.
Yeah, thank you very much. I think that's a very good point, that there are that you could distinguish between the two. Then I would like actually to take a quote from something that Jubei said for a couple of minutes ago, or 5 or 10. You said, but this is not true teamwork. And I think that is an interesting perspective. So when is a PBL competence actually true? When is it true creativity? When is it true collaboration? When is it true project management using the structures that you have presented, Tom, and you have presented, Johannes? When is it actually true? Could I get some, and I would like to open the floor for anyone having an insight on that. When is something a true competence? That is the hard one, right? Yeah, well, then let's let that dwell a little bit and combine it with another thing, because this is also a session where we have future competences too. So what is actually, from your studies here, what is actually the core competences if we should look in a future perspective of engineering? What would you then point to as the core competence? Jubei, you have something on performance, interest, recognition. What should be recognized in the future as a core engineering competence?
It's hard to say what is the core competence, because I think every aspect of those things are important. And students need to develop themselves in all aspects if they want to be successful engineers. Or yeah, it's hard to say what is core competence for me.
So maybe it's a combination of competences and variation.
Yeah,
that might be the core of the future. Then that could be one point.
Yeah.
Anyone else has a perspective on future? What should we lean on if we look at future competences? Tom, what do you and then Johannes, what do you think in your study that you would say go out in industry and employability perspective and see our BIM students here? We have a strong program because this is for the future, and you know why? This is because we have, and then you can proceed.
Yes. I think it's a bit unfair because we do a seminar with getting to learn digital, to take digital tools and to communicate and organize the work with digital tools. So of course our focus is thereon, and now I can stay here and say, oh, that's the answer. That's the main competence. But so, yes,
so
Johannes?
Can I follow up? I would think that the main competence from our course is that students can adapt these project and communications competences to other projects. So most of the engineers are also, so the projects in building industry are very different. And so when they have the structure or the methodology from BIM, they have to adapt this format to other projects, maybe when there are some other partners or some other building kinds. So I think the adaptation is the most, or the core competence.
Yeah,
yes,
please.
And maybe I'm just looking for another slide. Maybe I can I can share my screen again. Oh, my internet isn't working now. Maybe later. Today I presented a slide that most important is not the technology on its own, but the combination of the technology, of the people, of the processes, and of the guidelines, and to put them all together, because we won't be successful if we only know our technology, or if we only know how the process of planning buildings does work. But I think it's always a question of the combination. And doing this practical projects that improves the competences of combining technology, the process, yes, communication, collaboration, getting knowledge of the guidelines that I have to use for this work, yes, and all that together. Maybe yeah, together it's the most important competence.
Great. Now we have some reflections, and I'll just invite people to tell a little bit about. Catherine, you here? You want to elaborate a little bit on your comments?
Yes, do you hear me?
Yes.
Well, you were asking about when the students do it for real, when they get the competencies. And I believe, because I participated in the Latin American Solar Decathlon here in Colombia. And I also did a short study about the competencies throughout the project. And I realized that students definitely feel that they got those competencies when they do it for real, when they feel that they have to realize and materialize that project and explain that project to the community and get engaged with all the process. So when they feel that the result will provide something real for someone, will be help someone, they got engaged and they really feel that they got the competence.
Yes, I think it's really a good comment, because experiencing things, sensing things, and handling things, the tangible stuff, is very important. Thank you very much for that reflection. Liliana, you have a question? Liliana, are you here? Then I will move to Graham. You have an interesting point here. Can you elaborate a little bit on that?
Yeah, it's just a simple concept. I like Jubai's, hopefully I pronounced your name correctly, comment. It was really about, I saw it as you were trying to point out effective communication and supporting one another, then you can be more creative. There's several articles in research saying that by bringing in humanities, you can help create more creative environments. I actually feel was within our own teams, we actually use a very set process, a logical process, a bit like Tom's BIM process for communication. Because if you see for and against, say in a software architecture, in a discussion, you can perhaps think of a more creative answer. So I kind of feel as though one of the key skills for the future in engineering, and all three talks, Annette pointed out, Professor Annette Colomos pointed out a key thing. What is the different, what are the commonality between the first two papers, or perhaps all three? And I think it's about promoting communication and understanding of one another. And then you can create a better psychological or a safe environment in which to express your views. That's all.
Thank you very much, Graham. Liliana's microphone is not working, so I just posed the question. How does IBM improve person-to-person interaction, which I also consider important to professional engineering performance? Or BIM, I think it Johannes and Tom, person-to-person interaction? Any comments?
I can take this question. Yeah, I think the person-to-person communication gets a little bit lost, but I think there are also some job fixes and some things like this. So the project partners have to talk to each other every day. So at least the group leaders, and bring their information back to their groups. But I think the participants are forced to use a special communication way, and maybe they are learning to express themselves more exactly.
Yes, and I think maybe I can use it again. I think it's also a question of organization. So in our course, we are, as the teachers, we are the leaders of the project, and the students, they plan it. And it's important that you have coordinators, and that the students on their own define their roles. And so they know, okay, some parts of communication is done by the coordinators, and other things are communicated between the authors themselves. And yes, I think it's important that everyone at the beginning of these projects defines its own tasks, and that everybody knows who is responsible for which communication process. And that's new in BIM, that I don't only think of the thing I have to plan, but also to think which or what of my planning stuff has to be coordinated and communicated with others. Yes, and to see both, to see the planned building and the relating communication as my task, and to think of both, of what do I have to plan and of who do I have to speak with. Yeah, that's the most important part, and what we want the students to learn.
Thank you very much. Then Ida, you have a comment on the future competences. Can I ask you to elaborate that one? Are you still here, Ida?
Always the same thing. Oh my god.
Now it's working.
Now? What about now?
Yeah,
Yes?
I can hear you.
Yeah. It's about actually flexibility and adaptability. So actually students have this sort of plastic, a mind that it's not crystallized, that it's not fixed within a box in a frame, and they are able to adjust to the different situations and be critical. And actually, because each problem, each context, each situation call for something unique. And if you are not able to see that, you cannot adapt, you cannot be flexible. So I don't say these competences will stand alone, and they probably are developed in conjunction with others, critical thinking, reflection, but I think they are quite important. And as I explained, we have so many situations now. We have the sustainability issues, and then we also have the changes, the so fast technological changes.
You're a little bit low now on the microphone.
That it calls for that. It calls for this type of competence.
You're falling out, Ida. We cannot hear you anymore. So, but it was something about sustainability and being confident. And that we can agree upon. If okay. Yes, thank you very much. And I think I will start now to have some final comments, and I'll say to you that while I'm making my final comments in the last 3 minutes, you have the possibility to make yours in the chat. I just want to say to you, it's been very interesting. I think that Graham is very right, that this is about collaboration and communication, also for the students, their negotiation process, because after all, what is true and what is the future, that is different for each student, depending on the career track they want and depending on how they see the future. It's also different in the different sectors that we have. Now we have the building sector in this session. It can be different for other sectors. So I think this variation and this way of thinking about competences and the future is not something that we can define, but actually is defined together with the students and in communities. That's an important take from this session. So I would actually end this session by thanking you very much. And we have a last slide, I know. And Annette, will you shortly provide a few words with that for this slide?
Yes, I'm in the chat. So yes, we have a call for papers and a call for papers for next year. We hope, of course, that we will be in a situation where we can travel again, but most probably it will be a virtual conference. For the IRSPBL 2020, we have published all the proceedings, but we have opened up again for papers for 21. And if we cannot meet face-to-face, it will be on virtual ground. And we will try to learn from the conferences we have participated in so far, that we actually make it an advantage to also be in a virtual setting, and we are not only taking the physical conference meeting into the virtual environment. So is that what
Thank you very much, Annette. And Maiken, if you can then take the slides off so we can see each other all together, then I would just like all of you to provide an applause to our presentations and presenters and the different views. And thank you very much for your active participation in this session. I've enjoyed it very, very much, I can say from my behalf, and I can see that this is the case also in the chat for you guys. So thank you very much. And I hope to see you more in these flipped sessions for our symposium. Thank you and bye-bye.
Maybe, Ron, we can just talk here. You are muted.
I think maybe we can. Bart and I get together every Thursday early morning to discuss our research and things we're doing. So we would certainly.
But we need to get in touch and to see what we're doing right now. Yeah.
When we meet tomorrow morning, we will send you some potential times to visit, and you can choose, and then we'll.
Yes, please do. To have a catch-up meeting.
Yep.
And the corona here is crazy right now. The numbers are going like this in Europe right now. So
here too, very much.
Yeah, it's the same in the US, I guess.
Yep.
Yeah.
Especially just in our small community.
Yeah. Okay. But good to see you. And I have one grandchild now.
That's exciting. That's so exciting.
Good.
See you soon.
Ja. Og tak, Maiken. Det gik jo fantastisk.